Welcome and hello everyone. My name is Nur Ainumar Razia and together with me are my group members Nisa, Nurin Umairah, Nurin Inshira and Alia. Together we will be presenting about the application of state of matter and chemical equilibrium concept in aerosol inhalers. We will be explaining the key concepts and findings related to this topic. We hope you enjoy this presentation and understand the contents that we will be presenting. To start with, what are aerosol inhalers? Aerosol inhalers are compact drug delivery devices that rely on gas-liquid equilibrium to eventually disperse medication into the lungs. Inside the inhaler canister, a liquid formulation is stored under high pressure with a propellant, creating a dynamic equilibrium between the liquid and its vapor. The rapid phase change, along with pressure and temperature effects, makes inhalers an excellent real-world application of physical chemistry concepts such as the liquid gas equilibrium concept that we are presenting now. Inhalers can also treat respiratory conditions such as asthma and chronic obstructive pulmonary disease, which is commonly called as COPD, and other breathing difficulties. They work by producing a fine mist or dry powder that the patient inhales, allowing the medicine to reach the airways quickly and efficiently. Can help the airway muscle relax and reduce the inflammation, providing fast relief from symptoms like wheezing, coughing, and shortness of breath. Understanding these principles helps us to explain why inhalers deliver consistent doses and how formulation and propellant choice affect their performance.
In this system, a liquid medicine is combined with a propellant gas under high pressure, and when the inhaler is pressed, the pressure is released, causing the liquid to evaporate and form a fine mist of tiny droplets that deliver the drug into the respiratory tracts. For example, it's like when you open a soda can, the pressure inside drops. So, the liquid carbon dioxide quickly turns into gas and bubbles form. In inhaler, the same things happen.
Okay, so move on to the next part, which is the chemical equilibrium in an aerosol inhaler and why it allows each part to deliver a consistent dose. So inside an inhaler canister, there are three main components, which is the active drug, which is salbutamol, the propellant gas, which is hydrofluoroalkane, HFA, and the core solvent, which is ethanol. So this will form two phases inside the canister, which is the liquid phase, and the above it is a vapor phase. So liquid phase consists of mixture of drug and also propellant gas. So these two phases exist in dynamic equilibrium, which means that the liquid propellant will constantly evaporating back into gas, while gas molecule will condensing into liquid propellant at equal rates, which means that the inside the canister will have a constant vapor pressure, which is very essential for consistent dosing. But when the user press the inhaler, some vapor and liquid will release through the nozzle, which means that inside the canister, pressure will drop slightly and disturb the equilibrium. According to the Le Chatelier principle, system will contract by converting more liquid to gas. When gas escapes through the nozzle, pressure become lower. So more liquid propellant will evaporating into gas and restore the pressure, which keep the system balanced and allowing the inhaler to release the same amount of medicine in each puff.
For the next slide, what are actually the pharmaceutical importance? So I will briefly explain about why inhalers are widely considered an effective drug delivery method. Firstly, they ensure accurate and consistent dosing, where each actuation releases a fixed amount of medications, and the sealed device keeps the drugs protected from moisture and oxygen. Secondly, they produce controlled particle size between 1 to 5 micrometers. It's allowing the medications to travel deep into the lungs for optimal action. In addition, inhalers provided targeted delivery, where it's directing the drugs straight away to the airways and our lungs. It's making them especially useful for conditions such as asthma and COPD. Lastly, they are portable and convenient. Therefore, patients can bring it anywhere because it is easy to carry with their compact design.
Now, I will explain about the conclusion. How does the inhalers work? Inhalers work because of the concept of physical chemistry, or specifically states of matter and equilibrium. I will summarize what is happening inside the inhaler or the canister. The liquid propellant inside the canister will exert gas. It is said to be in dynamic equilibrium before the canister is pressed. Rates of forward reaction are equal to the reverse reaction. But what happens when the inhaler is pressed? More liquid converted to gas, or the forward reaction will increase. More droplets of medicine vaporized and delivered straight into the lungs. This process ensures that each puff gives a consistent and precise dose. The small size is to ensure that the drug reaches the deepest airways of lungs. Inhalers are also very important because they provide precise delivery of medication, and their portable design make people choose them over any other dosage forms like nebulizers, since inhalers are easier to be carried around. In conclusion, inhalers work by using physical chemistry principles to deliver consistent and precise dose of vaporized medication straight into the lungs, making them effective and also convenient at the same time, making them the choice for treatment of a respiratory system. That's all from us. Thank you.